Okay, so for today, we are going to talk about sampling procedures. So the question, overarching question for today is, and possibly we'll bleed into tomorrow or Thursday a little, but the overarching question is going to be, how do you pick people to study? Right? And so there are lots of different ways of picking people, but most of them are not good for the same thing. So just to make sure we know, so one thing you're going to have to decide, and all of you should, with your own projects, be figuring this out as well. The things that you're going to have to decide is one, what population are you interested in, right? So the population is the entire group of people you're interested in. You will all have different populations you're studying. So, if you are interested in prisoners in general, prisoners is a population. There's a lot of people in different prisons, so on and so forth. How you go about deciding who you're going to hand the survey to or who you're going to interview and who you're not, right, is essentially the logic of sampling. So how do you tap into that population, right? Because if you never study a population, you study a sample. Right? You study a sample. Okay. There's a couple of distinctions that need to be made. So you never have access to your overarching population usually. You might have been small enough, like you were talking about doing, well, to some degree, when you were talking about doing African American students at BC, right? You're actually interested in African American students at conservative colleges in general, right? So in some ways, that's your population. But it's not who you're drawing information from. Who you're drawing information from is just BC students, which is in some ways a matter of convenience, right? In that case, you would have a population African American students at religious art schools. And then you would have what you could call a study population. And by study population, you have, in this example, BC students. So what you're drawing from in your sample, right, is BC students, even though what you're interested in is something larger, right? Inevitably, if you're actually sitting down and writing about this later on, you'll have to justify your choice and why it works, right? But nonetheless, this is often a distinction, right? So the population is what overall you're interested in. Your study population is who you look at, right? All that clear? Okay. And this is different from something else, which is your sampling. And this is kind of more in the language of statistics, but we'll see some other ways of sampling that don't rely on this sort of stuff. But your sampling frame would be essentially, particularly if you think of a list of people that you draw from, right? That's your sampling frame. It's like a list. So a good example of this, if we were to take something like, we're coming up on election polling, which is just really, in a lot of ways, taking samples and asking questions, right? It's a form of research. And they try to be representative. So what's their population? If you're thinking about if they're doing, polling to see who will win a presidential election, what population are they interested in?
Would it be their particular people that side of that party?
Well, not necessarily.
Or,
right?
or is it just like the American people itself?
Yeah, it would be, well, we could get even more specific. We're going to talk about the percentage of Americans, right, who are actually going to show up and vote in an election. That's what you're interested in getting, right? That's your population. The voting population of the United States of America, right? So the study population would probably be pretty close to that, right? They usually draw on something really broad, right? So the study population in this case might agree, right? Unlike the example we gave before, the study population here is also going to be the voting population of the United States. Now, does anybody know what lists they usually use to determine who they're going to interview? This is going to show a problem with polling. Anybody know this? Telephone registries. Right? So, who shows up on a telephone registry? People who own landlines. Who owns a landline? Old people, basically, right? like, if you're under the age of 40, there's a good chance you're not going to be selected, right? A lot of polls that you'll see on the news still use that as a frame, right? A sampling frame. That's probably going to lead to some really bad results, right? So your choice in here often will lead into whether you're actually studying what you think you're studying, right? So you got to make sure that your population matches your study population matches your study frame, right? That's even before you do any of the samplings. We haven't selected a single person yet, right? These are just the tools that come beforehand. Okay, from there, the choice you would have to make is what kind of sample you're interested in. And the types of samples are going to be tied to different types of studies. There's a reason why people do that. So generally they divide sampling into two different types, non-probability sampling and probability sampling. We're going to start with non-probability sampling. A lot of times they have different goals in mind. So like where we kind of started talking about things like election polls, often you're trying to find a group of people in your sample that are representative of the overarching population. This is not true of most forms of non-probability sampling. It might just not be what you're trying to do, right? If you are trying to do that, the best way to go about doing that is probably probability sampling. And if people don't do it, it's usually because there's some restraint on their research that keeps them from being able to do that. Make sense? Okay. So there's a variety of other ways in which you sample. Qualitative stuff is far more likely to use non-probability sampling because usually they're not trying to make claims that are supposed to be representative of the overarching population. They just see what they see amongst the people that they're seeing, right? Make sense? Okay, so one form of sampling is convenience sampling. It is, by and large, the least likely to get you anything representative. So a good example of a convenience sample would be when the news has a tendency to interview people. Has anybody ever seen the news interview people, like particularly like television news? What do they just do? How do they come across people that they're interviewing usually?
Something has happened.
What's that?
Something has happened to them, or like they're trying to tell us.
So sometimes it's like the people involved in the stories. You ever see where they do like, and that's a good point, do you ever see where they do like views from the street kind of thing, right? Like, and they just like go out someplace and they just show up, right? So like, you know, some controversial thing happens in a town. They just show up in the town, pull up on some busy street, get out and just start walking up to people. And that would be an example of a convenience sample, right? A convenience sample is literally you come across what you come across, and the only reason why you're selecting the things you do is because it was the easiest thing to find, right? How accurate is that as a representation of, and often the news tries to do that as something representational, right? They'll be like, this is the attitudes of people at Atchison, Kansas about X, Y, and Z, right? And it's just the first 4 people that they come across. How good of a sample is that, probably? Yeah, not very. Can anyone think of moments where a convenience sample might work okay? There are times when researchers do convenience samples. So I think of things like sometimes if you get something like people trying to display some theoretical idea by looking at something in the mass media, and it's just a really good example of something, right? Has anybody ever read anything like that? This is kind of like almost like how literary critics or people in the humanities will often write, are often the basis of convenience sample. It's just what they come across, and it's an interesting example of something. You can't make a representative claim, but you can display something with a convenience sample nonetheless, right? So it's not always inappropriate, but it is really bad at getting representations. It's also really bad at capturing the breadth and width of what's out there at all, right? So you don't get a lot of variety in a convenience sample. Okay. A really common one for qualitative researchers is snowball sampling. Snowball sampling. And so, did anybody catch from the book what a snowball sample was? Yeah.
Like you interview someone and then you ask them to give you other people to interview.
Yeah, you use some of your research subjects to find more. So can anybody think of when you might use something like that? There might be some good examples of when you use it.
Maybe if you're doing like historical research, you can, like in your interview, somebody can ask like a call of the event you're studying or something.
Yeah. So if you're talking to a small group of people and they're involved in something, you could use them to find each other. That's a good example. When else might you use a snowball sample? Often you use a snowball sample if it's a group that you don't easily have access to. Either because it's like some sort of clandestine organization where they hide their identity, or even if it's just like a remote location and you can't just like pool people or get in contact easily, right? That's often when you use it. So I took a graduate level course on somebody who was like an expert in new religious movements, which colloquially we just call them cults. And, how do you interview cults? Well, you don't just like show up at the cult headquarters and be like, hey, I want a representative sample of cult members. Like, is there a list that I can get so I can call them up? No, that's not how you do it, right? You meet some person, and really often this involves things like building up trust with people, right? And that's something that snowball sampling is really good at, right? So you really need to build people's trust. You get a handful of people, you interview them, you interact with them, they know that you're not going to present them in a really horrible light or something like that you're not looking to not looking to screw them over, right? You're just like there trying to figure out what's going on. And as you build trust, you can keep on building out, right? And that's very common for qualitative researchers. Yeah?
Is this still under like the umbrella of non-probability sampling?
Yeah, because there's not, you don't have, and so the difference with non-probability sampling is like the ideal of a non-probability sample is not that each individual person is equally likely to end up in your sample. Right? That's what makes it non-probability. So like, in this case, your goal is just to tap into people and talk to them, right? It's not to, it's not to necessarily get some sort of representation of what the group is like. Make sense? Yeah, and a lot of times, yes. Anthropologists use this form of sampling a lot. So if you've ever taken like are any of you guys in ethnography? Ethnographers like this form of sampling because often they're going places where they don't really know the population, so they become really reliant on other people. It's just tied to, related to, but not quite the same thing as the use of informants. There's a whole like section on the use of informants. Did anybody pick up what an informant is in methodological parlance?
It's just using someone talking about the topic or person you're trying to introduce.
Not quite.
Someone that like understands them.
Do you have?
I think like it's like people with like inside information that can provide you with like the inside perspective.
Yeah, well, and it's particularly like people you use to figure out where to look. So it's like people who really know a group of people well. So like in a snowball sample, it's often more like thinking about like the example in new religious movements. It might be that you like know one person in a cult, and like that's your one person. They might not be super well connected even. It doesn't really matter, right? But it's like you're in. And so you can use that and just sort of follow wherever that chain leads, right? With informants, it's different. You have access to somebody who really knows the group of people and is usually central to it, right? So a lot of times this might be somebody who's like politically connected or just somebody who's really socially connected in, right? And they'll tell you where to look, who to talk to, things like that. Just to give like another example, when I studied in Senegal, I was with the West African Research Center, and one of their people that they used a lot as an informant was this guy who was really connected in with the rap culture of Dakar. But he knew everybody. So if you asked him, he almost always knew somebody you could talk to find a given group of people, right? And he often worked as an informant. Not paid, right? He just like would connect researchers with people. So that would be an example, right? That's often how that works, right? Anthropologists also use, anyone doing ethnography often also uses the use of informants a lot. Okay, any questions about those so far? Okay. The last form of non-probability sampling that we're going to look at is what's called a quota sample. Now with these two, going back to like the goal is not to get representation. Quota sampling is a little different because the goal is to get representation. The goal is to get representation, but for some reason you are not capable of doing a probability sample, is usually when you would use this. And so kind of what you do in a quota sample is you would try to near the size of the population, right? So a good example of this is if, let's say you were doing a study, and let's say rather than at BC, it was at a different liberal arts school, and hypothetically you were interested in people's religious views, right? And so at this other liberal arts school, they have 2,000 students. And out of these 2,000 students, 1,000 of them are sort of like mainline Protestants. 600 of them are evangelicals, and 400 of them are Catholic. And let's say you wanted to draw a sample of, even though this would be a pretty large sample, let's say you wanted to draw a sample of 200 people. right, out of this 2,000 and interview them. What you do in a quota sample is you would get 100 people, 60 people, and 40 people from each category. And so that's how you would draw your sample. So rather than using some form of like random selection, you would instead select on the basis of which group they belong to. Make sense? A lot of times too, people will use quota sampling. So it's when you can't do probability sampling. Does anybody know how many people you have to actually interview or survey to have probability sampling work out if you're doing something like statistics? Does anybody know this? How many people you need to do statistics? It's around 1,000. So if you can't get 1,000 people, it's not always worthwhile doing a probability sample. Now, that's true scientifically. It's not necessarily true in terms of if you're trying to get something published. Often they want you to do a probability sampling, whether it makes sense or not. You're also like, in terms of like most forms of statistics, not true if, did anybody here take statistics yet? Okay, some of you guys, I'll throw out things about statistics every once in a while. If you don't know what I'm talking about, just shut your ears off. But like chi-square, you don't need that many people, but for something like regression, correlation, things like that, you really do actually need to have 1,000. So it depends on like, you know, but also like probability sampling doesn't necessarily help you with smaller amounts because they're not designed for that. So anyways, the point is that if you're drawing a particularly small sample, you might use quota just to make sure that you're representative, because all you're going to actually probably do is descriptive work on them anyways. Also, like if you're doing a qualitative study, and you're not usually going to do a qualitative study on 1,000 people, you might use quota sampling if you wanted to have something representative, but you're only going to interview 20 people, right? And so you might use quota sampling in that situation as well. All make sense? Do you guys kind of see how, and this is something I've been trying to like capture a little bit, how early on we started making, and you know, maybe you didn't make the decisions yet or not, but we start making some decisions, but then as you move on, right, your early decisions is going to have a lot of impact on your later decisions in research. They're interconnected. So if you pick something, you know, if you decide to do a qualitative study, you're going to do very different sort of things than if you're doing a quantitative study. If you're doing something descriptive versus explanatory, it's going to make a big difference what you're doing, right? Because like, do you need to have representation? Do you not need to have it, right? So all these things are really massively interrelated. Also, there's almost never one good way of doing things, and you just have to figure out which one works best for what kind of question, right? Okay. Any questions on this? This sometimes gets complicated. I did a really simple version, but sometimes you'll do quota samplings across matrices, so then you might do things with different cross sections of variables. So you might be interested, rather than in just religious, use religious and political, and then you have to also figure out like what political party people identify with from that same population, and then you would essentially kind of create a grid and figure out how many Protestant conservatives, Protestant liberals, right, so on and so forth. Sometimes when people do this stuff, 6 or 7 different variables, so it can get really complicated depending on how you do it, right? Okay, good on non-probability? No, I don't talk too fast, do I? You guys are capable, okay. Just making sure, don't want to lose anybody. Now, it's also worth mentioning that not all sociological work is even going to try to use any particular sampling frame at all. There's other philosophies on this, so like, or sampling method at all, there's other philosophies on this, and a good example of this is like, if you're in a class and we read something that's supposed to be like post-structuralism, right? There's a certain theoretical framework, and they might be like, anything that gets said is fair game within this particular theoretical construct, right? Like, you know, so there's an example of this post-structuralists always talk about discourse, right? They're interested in analyzing discourse. But they'll say things like, If it's a part of the discourse, then it's fair to analyze it. In other words, like you shouldn't necessarily give any precedent to one sample or another, right? So they don't really care about being representative. Right? That's one example. Another thing is like, this would be a good example of this would be a lot of historians talk about that they're not trying to actually represent what happened, they're trying to construct a narrative, something called narratology, right? They're going to make no attempt to actually get representative samples if that's their goal, right? So like getting back to like, the book doesn't really present it this way, but there's often a lot of room for breaking these rules as well. Okay. So there's less types of random samples, but more. It's good to kind of like focus on how this is done. So I'm going to actually show you how to do some of this. Okay, we throw the word random around a lot, but when social scientists use the word random, they mean numerically random, which is actually very different than what we think of as random. So you would think on the surface, if I just like, I don't know, closed my eyes and picked somebody, that would be random. But mathematically speaking, it's not. Actually, in fact, most of what we think of as random and our perception of randomness as human beings is actually pattern. So we can't trust our own feeling of whether something is patterned or not. Does that make any sense? Human beings, another way to put it, human beings, their brain naturally makes patterns where there is none. So like, you have to, like, if you want something to be random, you actually have to make it random. Right? And there's certain ways of doing that. One is that you can literally find a list of random numbers. I made a list of random numbers. And then you can use those random numbers to select groups of people. Right? Select your sample of people. Make sense? Okay, I'll give you an example. So if I was to take as my sampling frame all of you guys, there we go, and I've assigned you a number. Now, for some reason, when I downloaded this to the computer, it changed my numbers, which is kind of annoying. So this is supposed to be 0, 1, 0, 2, 0, 3. You guys see that? This is how you normally do it. So you take that list of people and then you would assign everyone. So you take your sampling frame, and this is an example of a simple random sample, right? You take your sampling frame, you assign everyone a number, right? And depending on how many people, so if you have less than 100 people, you do 0, 1, all the way through to whatever, right? If you had more than 100 people, you do 0, 0, 1, all the way down until you got to the total population number, right? If you had 1,000, it'd be 0, 0, 0, 1, right? Make sense? And then what you do is you essentially take a list of random numbers, and then you do the first however many numbers you have. So if that's, in this case, you're going to take the first 2 numbers, right? Because you have less than 100 of you guys. If you had more than 100, you take the first 3. If you had more than 1,000, you take the first 4, right? So on and so on. Okay, so you start at the top and you just move down. So anybody feel like gambling with an extra point or 2 today? Sound okay? You want to gamble with extra points? Is everyone okay with like assigning somebody random extra credit points for being selected? Okay. So this is entirely random. I have no choice in it. So let's go through and let's pick let's pick 5 people. So take those first two numbers, so in this case it would be 3, 1, and just go down the list. What do you get? Well, you get 1, 2, 10. So Garrett, who is home on quarantine, I'm going to be cheap and only give people 1 point. I know that's lame. Okay, go down, 11. 11. It's 1 point. Juliana here? Okay. So, okay, and you just go down. This is 19. 1 point. Okay. Right there. 12. 1 point. 1 is 1 point. Okay, so that's in essence how you would take a simple random sample. I actually always use this. This is really nerdy, and you can judge me for that if you want. This is how I select who will go first in presentations. I just do a simple random sample. It's entirely up to probability, fate, whatever metaphysical concept you want to.
So where do you get all these decimals at?
Oh, this, you can make this chart really easily on Excel. All you have to do is hit the RAND equation, and then just fill it in. So anyways, but yeah, there's also, so if you wanted to ever use a random number chart, there's actually one in the back of your book. So I use that because you could see it. And so this is also an example of a random number chart that you can use. You just have to make sure that you move through it consistently is the only thing. And if you do that, it's completely random. Now, also pointing out this idea of pattern versus random, like what's mathematically random always feels wrong. Like in this case, and I didn't even know which numbers I selected until I showed up today. We ended up with 3 people right in a row alphabetically, right? So there's that. Actually, we have a disproportionate number of people who are absent today, right? We've gotten more and more people in here, right? Most of you guys are gone, yet half of my sample isn't here, right? They're going to be watching this at home. And then they'll figure out that they had a 1 point extra credit. But anyways, so that is in essence that's why we can't trust our feeling of randomness. Okay, any questions on how you take a simple random sample? What might be a downside? So mathematically this is great. What's a downside to doing a simple random sample? What do you think? So let's say rather than pick 5 people, I wanted to pick 2,000 or 3,000 people. What would be a downside to this? Yeah, which is why the reason why pretty much nobody does a simple random sample. It's exceptionally time consuming. It's very slow and tedious work, right? It only really works if you have a small number of people. Make sense? Okay, so that is a simple random sample. The next type is a systematic sample. And I wonder if you can see this if I write it. Can you see that still? Okay, cool. So in a systematic sample, you start with a random number and then pull every so many, depending on whatever number you preset, people, right? So I'm going to say, to illustrate this, do a systematic sample. I'm going to pull every 3rd person. So I'm going to pull from column J. We got 13. So that's going to be Bridget. And so then from this, you would simply, and this is oh so random. I'm going to, okay, so every third person, 1, 2, 3, or sorry, 1, 2, 3, 1, 2, 3.
You messed up.
You must
What?
you're counting.
Oh. Sorry, folks. Hopefully you didn't get your hopes up. Okay. 1, 2, 3. 1, 2. Oh, no, that's right. So those are our random people selected through that, right? So it's random because it's only random because the number we start on is random, which means that every selection after that is still random. Does it make sense? So it's a lot quicker way of doing a sample, right, than the other way. And that's really its only advantage. Now the disadvantage to it, and I'm not going to explain this because you can figure this out in statistics, is something called sampling error. Mathematically, our idea of randomness as we plotted it mathematically, this is also not completely random. There's a margin of error, and that margin of error depends on the size of your population and other things of that nature, right? But anyways, that will determine how likely you are to make an error in your randomness, right? There's a higher degree, because essentially, there's a higher degree of sampling error for systematic sampling. Okay, all that clear so far? So when I showed you the first one, I talked about that what appeared to be random wasn't, right? That there are problems that we pulled from a small area of our sampling frame, right? There's also a lot of times problems too, like you have to be careful that your sampling frame doesn't have, like, so if you were to look at a roster of students for a study, right? How are the roster of students often going to, if there's a master list of students that the college had, what might be some things that they organize that from, based on?
Alphabetically.
What's that?
Alphabetically.
They might organize it alphabetically. How else might they organize their records?
Like class of freshmen, sophomore,
Yeah, and if they did that, then that would pose certain problems in drawing samples. Why? Well, let's say if we were to list students by their class standing, and generally speaking, you guys are juniors and seniors, right? In our second sample, we might not have got anybody from one of the classes, right? So there's a problem there. There's a danger to that, right? Or another good example is that for the first one, we ended up with a really disproportionate number of people who are absent. So these are other forms of things that can get in the way of your sampling that don't have anything to do with the bias of selecting, right? The selection was completely random, but we still might not get the information we're looking for, right? Does this make sense? And so often what we do is we will take this sort of simple random sample. We can take this simple random sample, or the stratified random sample, or the systematic sample, either or, and we can do what is called a stratified simple random sample, or a stratified systematic sample. And what you do then is essentially it's sort of like a mixture of, remember we were talking about the quota sampling earlier today, right? Where you're pulling from certain groups. It's like that, but you use randomness within each category. So like, you know, you want to make sure you have X number, you know, of juniors or seniors in your sample. What you do in a stratified sample is you would take that sampling frame, that list of people, you'd break it into categories, and then you would randomly select a proportionate group out of those two different groups. Right? Make sense? This is sometimes useful in gathering information. It's mathematically weaker. Right? So there's more room because essentially that ideal of everybody has an equal chance of being selected. Well, not everybody in your sampling frame might have an equal chance of being selected. It's going to depend upon your quota, right? But you will make sure that you get people from, so it may, mathematically may not be best, but it might actually be better in terms of your results. Make sense? You might actually be measuring what you say you're measuring. It might be more valid, even though it's less mathematically true, and therefore it's probably less replicated. Okay, make sense? Okay, there's one more form of sampling I'm going to do. So all these are good techniques for most statistical studies, particularly if you have a small enough sampling frame to deal from, right? If you're dealing with a small enough population. It gets really hard though if you're talking about very large populations. So if you're interested in, you know, people in Atchison, Kansas, and you I don't know if you can do this, but if you pull DMV records and have a list of everybody, you know, who owns a car in Atchison, Kansas, and and you take a random sample, like that's pretty good. There's going to be a bias to that, right? Because who doesn't own cars? Who doesn't own cars usually? Yeah, so there's going to be some bias, so it would be a bias in the sampling frame, but this by and large would be a fairly decent sample, right? But you can't do that so well if you're talking about instead drawing a sample of the population of the United States of America. There's no great master list of Americans that is going to be short enough that you could use any of these procedures on, right? So instead what you do is you do something called a multi-stage cluster seed. So sticking with our example, you could, let's say, you have, good old US of A here. I'm not an artist. My dad is, and you'd probably be embarrassed to see how poorly I can draw. But anyways. He's not an artist, he paints signs for a living, but that's kind of close. Anyways, so if you're thinking about the United States, right, and you're going to do a multi-stage cluster sample, essentially you're going to take bigger chunks of people, randomly select those people, those chunks, and then you're going to go down, 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 right? So you may take and this may still be too large, but you might take a list of counties or townships. And usually, you're probably not states because 50 is not too many to draw from, right? But you might do a list of counties or townships in the United States, and then you do a random sample or any kind of probability sampling, right? Random sample, stratified, random sample, systematic sample, stratified, systematic sample. Then you'd start, you'd do the one, right, at that level. And then you would go down and you'd have some other sampling frame from that list of counties. And then you would pull, or townships, and then you'd pull from that. So you might have, you might do counties, then you might do towns, and you might do, and you can do as many as you want, right? So it just depends on how hard it is to get access to a short enough list of people. So you might do towns, and towns, you might do streets, and then you might do houses, right? And then you might get down to your people. Make sense? So one thing that you have to have for this kind of sample though is you have to have things kind of drawn up somewhat equally. And what I mean by that is you can't have vastly different ways of organizing things across each other. So you're going to get very little research being done internationally statistically, and the reason why is because often you can't cross between countries very easily because what they define things as, how they measure things, don't really line up. So you wouldn't necessarily do that, right? So that's one thing you would look for. There's a problem here. And I'm not sure, did anybody catch this issue? There's a big long section on this, and I know like this is kind of a confusing way of talking about, most confusing form of sampling I think we talk about, so.
It's not as accurate.
I mean, what do you mean by not accurate? What are you thinking?
I guess whenever you pick who you want, or I guess it's not as random. I mean, you can kind of pick how you want your clusters.
Well, as long as the selections high up are still random, then it's still, at least mathematically speaking, random. Yeah.
Is it too big of a, sample? Is there too mistakes?
Well, you could draw whatever size sample you wanted doing this. So even if you just wanted a small number of people, you could still draw that many number of people. You just do it less times in a lot of ways, right? You'd get less households at this end, right? It's that each of these sampling frames have their own problems, right? And you're creating error each time. So any errors that you take from this one would be compounded by more error here, because nothing is perfect, right? So any problems that you have with your sampling frames get compounded upon each other. So like, in that way, yeah, they're less accurate, right? But they're less accurate because essentially it's like each time at each level, mistakes add up, right? So it decreases the probability that you're actually getting something random. Which, if that's bad enough, and there's ways of measuring that, they're not complete, right? And this is going back to like the sampling error would be a numeric version of error. And each of these would have a certain sampling error. Those things are going to add up more and more as you go down, and they're going to compound upon each other and get worse. But there's no way of getting to a really large population otherwise. So as a general rule, if you're looking at statistical studies, the larger the group, the original study population is, the sampling population, right? Not the study population, not the full population. The larger that is, the worse, the less likely the information you're presented with will be accurate. So that's kind of. You guys get how much guesswork is involved in doing research, by the way? Yeah, there's a lot of uncertainty when it comes to research. So we got to be careful. There's a really famous philosopher by the name of why am I going to blank on this? Bolton? No. I'm going to look at the book and get back to you. I wasn't planning on talking about this. It just popped into my head, right? But talks about the Janus face of science a lot. And the idea of the Janus face of science is that researchers talk about what they do differently in the moment than they do when it's complete. So the idea is like, if you talk to researchers who are actually researching, they're very aware of the likelihood of whatever they create is probably not all that accurate, right? There's a lot of danger for error on the one side. Yet, we have a tendency on the other side as scientists to be like, no, what I found is true, and you have to accept it because it's science, right? And there's kind of a weird contradiction here. So just something to be kind of aware of, right? Like, the real act of research, the real act of doing science is messy. And it's a lot of problems that you have to solve and make decisions about how to solve and don't do very well. That's why actually, like, when you guys read peer-reviewed journals and they do the method section, it's just like this whole slew of decisions that they made. And the reason why is they're just trying to be open and honest about all the crap that they did so that people know what they did to get the results, right? But those things actually, in a lot of ways, read like a laundry list of decisions which may or may not have been good, right? So like, that's really what that is, that long, boring section in the middle of an article. We're actually going to look at some of those in detail once we get a little bit more attuned to how you make decisions. We may even, try to sensitize ourselves in points where people actually probably make, because sometimes too, people don't actually follow the procedures that they're supposed to, right? Like, they may be making statements about as if it was representative, and then they're just using a convenience sample, right? You'll find research like this, sometimes very famous research, right, that people would accept, and this is back to the Janus case, people would accept as being universally scientifically true, and yet it's built on something very fuzzy and human on the other end, right? So it's just something to be aware of. And also, like, in terms of how much you can actually trust the things that you read, right? Human beings are just kind of guessing their way through figuring crap out. They don't really know as much as they let on. And that's actually kind of true regardless of what area. It's true of the hard sciences too. And a lot of times the things we perceive as scientific aren't as scientific as we think. A great example of this is, if you were to poll people as a general rule would think that economics, right, is a lot more scientific than sociology. Yet, often the way in which they use statistics actually means that they're less accurate. Like, if you look at a statistical study in the United States, they'll control first. We talked about control variables before, right? So like control variables are just things that you make sure, right? So in sociology, people will have maybe 5 or 6 control variables, because the more control variables you have, the less accurate your information is. If you look at an economics article, sometimes they'll have up to 30 or 40 control variables. Like, at that point, like, the statistical test is probably invalid. Right? Yeah, right. In public perception, one's more scientific than the other. Same with medicine. Medicine will often do the same thing. We would perceive medicine as very scientific, right? In sociology, it's less so, but that's not really how it works. So in a lot of ways, in short, like, we're all kind of guessing, right? But like, there's better or worse ways of guessing, depending on how you ask your questions. Okay, any thoughts on sampling procedure? Is all this pretty clear? So I will expect you also within your study to pick a specific sampling procedure that's going to work with it, right? That's going to be part of your research design as well. Is this getting more concrete and understandable as we move along? I'm hoping by this point we're getting into things that feel a little more nuts and bolts like. Okay, great. We're going to talk about experiments on Thursdays. Something none of you will ever do, but you should all know how they work. Have a good day.
Me too.
So are you planning on joining the military after this? What are you
Yeah.
gonna wanna do in the military?
So it's broken down kind of like, Army obviously is the branch I'm going into,
Yeah.
but like in the Army they kind of have like your job broken down into combat arms support, and then just support.
Yeah.
So I want to go combat arms, which is like infantry armor,
So you
field
wanna
artillery.
do the dangerous stuff.
Gotta have some fun with it. But, yeah, so I'm an ROTC here, and I got a national scholarship out of high school.
Cool.
So then with that, you have to serve so many years after college. But
Okay.
you
Cool.
commission as a second lieutenant whenever you get out.
Cool.
So
Well, great.
it's flying.
So you plan, is this like, you wanna be a career man, like retire
Yeah,
from it
I
kind of
mean-
thing?
I've talked about it with my dad, and I've had like other family members in it.
Your dad's in the military?
He was in for a short while, and then my uncle was in, and I've had 2 cousins in recently.
Cool.
And I mean, none of them went career, but I had a grandpa that went career, and he's like, the benefits he